Now, I've put this in perspective. Let me teach you yet another rule of differentiation, which is called the chain rule of differentiation. That's the chain rule of differentiation. Derivative of y with respect to x is derivative of y with respect to some t into derivative of t with respect to x. That means if you want to differentiate y with respect to t, with respect to x, right? This is differentiating y with respect to x, derivative of y with respect to x. Then you could instead do the following. Suppose y is talking only to t. Y is talking only to t and t in turn is talking to x, right? So what you do is, since y is talking to t directly, you might want to say that dy dx is like dy dt into dt dx. Make y, cause y to be differentiated with respect to t and then cause t to be differentiated with respect to x. That's going to give you the derivative of y with respect to x. Mentally, although technically inappropriate to suggest, but you can imagine as if, for the sake of an algebraic understanding, you can imagine as if this dt dt are getting cancelled and you have like a dy dx. Only for the sake of a mental comprehension, you can carry this algebraic notion in your head that, well, this ought to have been the case because this dt dt got kind of equivalently cancelled and you have like a dy dx which is like a dy dx. That's a mental picture you may want to carry, although it's inappropriate technically to say that, right? But of course, it would be that inappropriate. I'm going to down the line look upon. Right now, I'm looking upon this as ddx of y. But down the line, when we mature to a certain point, then I would also look upon this as a very, very small change in y divided by a very, very small change in x. In which case, I can actually look upon this as a ratio of dy and dx. And once we start looking upon this as a ratio of dy and dx, that's when, this cancellation of dt would look fair and fine. But until then, it's inappropriate to call it even dy by dx. It's like ddx of y. That's the right thing to say till such time that you figured out that this ddx of y is equivalent to a very, very small change in y, which we would refer to as dy, and a very, very small change in x we would refer to as dx. That's when that algebraic notion of the ratio would stand justified. But in any case, this is chain rule. For example, y say is sine and t is x to power 8. Y is sine t and t is x power 8. And you want to differentiate y with respect to x. You want to differentiate y with respect to x. Hey, but y is talking to t. Is not talking to x directly for some reason. And t in turn is talking to x. Right? Y is talking to t directly and t in turn is talking to x, but you want to differentiate y with respect to x. Then what you deploy is what's called the chain rule of differentiation. That means cause y to be differentiated with respect to t and then cause t to be differentiated with respect to x. So it's like dy dt, cause y to be differentiated with respect to t with which it's directly communicating, and then cause t to be differentiated with respect to x. That's the chain rule, right? So now when you differentiate y with respect to t, that means sine t with respect to t, what would you get? Cos t. Differentiate t with respect to x. That means if you want to differentiate, t is x power 8. X power 8 with respect to x would give you 8x power 7. 8x power. Right? Pardon me? Not sure about. Yeah, I'll explain this again. This is the chain rule of differentiation. Say there would be instances where y is directly talking to x. like this case, y is sine x, y is directly talking to x. Then you differentiate y with respect to x and you get derivative of sine x with respect to x as cos x, right? But there could be instances like this when y is not directly talking to x. Y is talking to an intermediate guy called t. T in turn is talking to x, right? But you want to differentiate y with respect to x. What you do is, well, since y is directly talking to t alone, you differentiate y with respect to t. And then differentiate t with respect to x. Now differentiating y with respect to t means, y is what? Y is sine t. That means differentiating sine of something with respect to something. What would you get? Cos of something. If you differentiate sine of something with respect to the same thing, you get cos of that thing, right? So then differentiating this with respect to this is going to give you cos of this. Is going to give you cos of this. And then differentiate t with respect to x. That means differentiate x power 8 with respect to x. Differentiating x power n with respect to x gives us nx power n minus 1. So that's n x power n minus 1. Right? Now, for example, I hope you're all there with me on this. In any case, I'll inundate you with illustrations here and you will be forced to understand everything that I'm suggesting you. Suppose y is sine of cos of x and you propose differentiating y with respect to x. Now, what we know is, see, this is what we've learned in verbose. ddx of sine x is cos x. That means we've learned derivative of sine of something with respect to that thing is cos of that thing. Derivative of sine of something with respect to that thing is cos of that thing. But this is, I want to differentiate sine of cos x not with respect to cos x but with respect to x. If somebody said differentiate sine of cos x with respect to cos x, then that's not an issue. That's going to be cos of cos x. Differentiating sine of abracadabra with respect to abracadabra will give you cos of abracadabra, right? Yes or no? Right? So differentiating sine of cos x with respect to cos x is going to give you cos of cos x. Cos of cos x. This cos x is that abracadabra, right? But differentiating sine of cos x with respect to x is not going to give you cos of cos x, right? And this is where chain rule comes in mighty, because you may then want to write this sine of cos x. You may want to write sine of cos x as sine t. You may want to write sine of cos x as sine t, and then in turn write t as cos x. Then in turn write t as cos x. And now you want to differentiate y with respect to x. But y is talking to t, t in turn is talking to x. So might as well differentiate y with respect to t and then differentiate t with respect to x. So to be able to go from here to here, what you do is you go from here to there and then into t to x, right? So differentiate y with respect to t and then t with respect to x, t with respect to x. Differentiate y with respect to t and then t with respect to x. Differentiating y with respect to t means differentiating sine t with respect to t, but differentiating sine t with respect to t is going to give me cos t. And then differentiating t with respect to x is like differentiating cos x with respect to x, which is going to be minus sine x, precisely minus sine x. And then t was a guy you brought from outside for your convenience. Now might as well have him go out. T, well, no, t is cos x. So you might want to substitute cos x here. So this is like cos of cos x into minus sine x. That is minus sine x. How about this? Sounds all right? Shall I proceed? Let's see. Bless you. I'll put the bless you in a loop now, I equal to 1 to 10. Oh, okay. Now, say I want to differentiate y equal to sine of log x with respect to x. Now, if I want to differentiate sine of log x with respect to log x, that's going to be cos of log x. But I want to differentiate sine of log x with respect to x. Sine of something with respect to something is cos of something. But sine of something with respect to something else is not cos of that thing, right? So if I want to differentiate sine of log x with respect to log x, which we want to write like this, differentiate y with respect to log x, with respect to log x. This is like differentiating y with respect to log x. That's going to be cos of log x, all right. Differentiating sine of log x. Why is sine of log x? Differentiating sine of log x with respect to log x. This is with respect to log x. That's going to be cos of log x, all right. Right? But this is not what we are proposing. We want actually differentiate derivative of y with respect to x, not with respect to log x, right? What we then do is y is sine t, obviously, and where t is ln x, right? So you want to go from here to here. You say dy dx, differentiate y with respect to x. That's going to be differentiating y with respect to t first, and then differentiating t with respect to differentiating y with respect to t means sine t with respect to t. That's going to be cos t. And then differentiating t with respect to x is ddx of ln x. That's going to be by x. And cos t. Where is cos of ln x? Is cos of ln x. If I want to differentiate, say y is tan e par x. Tan e par x. With respect to x. If I want to differentiate tan e par x with respect to e par x, what would I get? Sec squared e par x. When I differentiate tan e par x with respect to e par x, then I get sec squared e par x. Alright, but I want to differentiate tan e par x with respect to x, right? So what I do is, I write this as y equal to tan t, y equal to tan t, where t is e par x, right? Now, to differentiate y with respect to x, but y is talking to t. So might as well differentiate y with respect to t first. So that's like differentiating y with respect to t, and then differentiating t with respect to x. Differentiating tan t with respect to t is going to give me sec squared t. And then differentiating t with respect to x, e par x with respect to x is going to be e par x, absolutely e par x. Where t is e par x here. So might as well replace this t by e par x. Sounds alright? Suppose I have now y is, first of all, what is ddx of x? 1, because this is x par n, so 1 into x par 1 minus 1, that is 1 into x par 0, that is, so ddx of x is always going to be 1. Now, say n is a constant. What is ddx of mx? M, because m scoops out. Being a constant, it's coming out. Then that's going to be into ddx of x. That's going to be m. So ddx of mx is m. Now if I had, let's say, y is sine mx, and I want to differentiate sine mx with respect to x. It's not going to be cos mx. If I differentiated sin mx with respect to mx, that would have been cos mx, right? But I want to differentiate sin mx with respect to x. What I do is I write this as y equal to sin t, where t is mx, where t is, right? So to differentiate y with respect to x, y is talking to t directly, so that's going to be cos t dy dt, and then differentiate t with respect to x, right? Differentiating y with respect to t means sin t with respect to t, that gives me cos t, and then differentiating t with respect to x, differentiating mx with respect to x is m. See, differentiating mx with respect to x will give me m, where t is mx. So I can replace this t by mx here, mx cos of mx into m. If I want to differentiate tan mx with respect to x, hey, if I differentiate tan mx with respect to mx, what would I get? X squared mx. But now I want to differentiate tan mx not with respect to mx, but with respect to x, right? So what I do is I write this as y equal to tan t, where t is mx. So then, to differentiate y with respect to x, we instead differentiate y with respect to t first, right? And then differentiate t with respect to x, Now differentiating y with respect to t is like differentiating tan t with respect to t. That's going to be sec squared t. And then differentiating t with respect to x, that is mx with respect to x, is going to give me m. Differentiating mx with respect to x is going to give me m. So sec squared t into m, where t is mx. So I might want to write this as sec squared mx into m, right? Where m is a constant. Similarly, y is cos mx. I want to differentiate this with respect to x. Same thing. Y is cos t, where t is mx. So differentiating y with respect to x is like differentiating y with respect to t first, and then differentiating t with respect to, right? Differentiating cos t with respect to t is going to give me minus sin t. Cos t with respect to t is going to give me minus sin t. And then differentiating t with respect to x is going to give me m. So this is like minus sin t mx into m. Now this was the two-fold chain or two-sum chain illustrated. We can have a little more elaborate chain. Have you got a hang of this two-sum chain? Right? But we can have chains that can extend to any length. For example, can I write this off? Say y is sine of cos of e power x. Y equal to sine of cos of e power x. Alright. What I do is I say, okay, y is sine t. Where t is cos t1. No. Cos t1. Where t1 is e power x. How about this? I write y as sine t, where t is cos t1, where t1 is e power x. That's a threefold chain, three-sum chain. Now, to go from here to here, what would you do? You would go from here to there, and then here to there, and then that means to differentiate y with respect to x, you would differentiate y with respect to t, then differentiate t with respect to t1, and then differentiate t1 with respect to, that's a three-sum chain, right? So essentially mentally, you can imagine as if this dt and dt are getting cancelled, as if this dt1 and dt1 are getting cancelled, you're left with the residual dy and dx. Just for the sake of a mental comprehension, that's all, right? Now, to differentiate y with respect to t, that means sine something with respect to something is going to give me cos something, cos t. Then t with respect to t1 is minus sine t1. And then t1 with respect to x is par x. Now, might as well put things back in place. T is cos t1, that is cos e par x. T is cos e par x, right? So, this is cos e par x of cos of t is cos of e par x. Yes or no? T is cos of e par x and t1 is e par x. So, minus sine e par x into e par. And this chain can go on and on and on and on forever. You can have a three-sum chain, you can have a four-sum chain, you can have a n-sum chain, and you can have very horrendous chain, right? Where do you stop? Where do you stop? And do you keep doing all this? If I were you, I wouldn't keep doing all this. This is so time consuming. If calculus was about just doing this, and if we had a long expression, I mean, if I had, let's say, y equal to sine of cos of tan of ln of sec of e par sine of x squared, etc., etc., etc. I would say, come on, let's move to commerce. If I had to do this, huh? Avogadros, yeah, right. And if you had to write so much of stuff, then that's not going to augur too well. What I'm going to tell you is the chain rule. You had to learn the chain rule because it was important for me to have told you that there is something like a chain rule, and this is the formal implication of a chain rule. But first of all, even before I venture into telling you something very simple, I want to ask you, have you understood the chain rule? All of you, no qualms. Then I'll tell you this. First of all, what you have to remember is ddx of sine gives me cos gives me minus sine, tan gives me sec squared, e par gives me e par, ln gives me 1 by, right? That's a picture that you want to bear in mind, okay? That's a picture that you got to bear in mind. And now, if you want to go from here to here, essentially you want to differentiate y with respect to x. So you want to go from here to there, right? Don't even constitute the chain in a manner that I described. That was a formality. What we would do is to differentiate y with respect to x. This is like nested functions, one inside another and going on till finally you arrive at an x somewhere, right? Go from outside to inside. This is outermost and this is innermost. Outermost is sine, innermost is e par x. Right? Now go from outside to inside. That's a rule that I'm telling you, so that you don't have to constitute a chain and spend a lifetime writing t, t1, t2, t3, t4, t5, tn, where n tends to infinity. Right? You don't want to do that. What you want to do is just go from outside to inside. The rule is just go from outside to inside. And then what do you do when you go from outside to inside? Sine, you should know, gives me a cos. So then, cos of whatever is inside, right? Cos of whatever is inside that. Then come inside and forget this. Cos gives me sine of minus sine of whatever is inside. Then come to the sanctum sanctorum. E power gives me e power x. Finally, e power x with respect to x is e power x. Let me illustrate more. Suppose y is ln of tan of e power sine of x cube. Okay. Don't get into the dirty job of writing variables t, t1, t2, t2, t3, etc. You will get lost in the chain. Go from outside to inside. ln gives me 1 by whatever is inside. ln gives me 1 by whatever is inside, right? So 1 by tan e power sine of x cube. Tan gives me sec squared. Tan gives me sec squared of whatever is inside. E power gives me e power. Then come up, going past e power, you have a sine. Sine gives me cos. So into cos of x cube. And then come to the derivative x cube, 3x squared, 3x squared. X cube would be 3x squared. The chain terminates there into 3x squared. Right? See, I've just gone from outside to inside. ln gives me 1 by whatever is inside. Then tan gives me sec squared of whatever is inside. E power gives me e power. And then come inside. Sine gives me cos. And then x cube gives me 3x squared. X cube gives me 3x squared. Are you all there with me on this? You would have arrived at the same result if you had constituted the chain formally. This is what would have happened in effect. Say y is tan of ln of sine mx. And I want to differentiate y with respect to x. Go from outside to inside. Outermost is tan. Will give you sec square of whatever resides inside that. Sec squared ln of sine mx. Then come inside and forget the tan. ln gives me 1 by, ln gives me 1 by of whatever is inside. So 1 by sine mx. Then sine gives me cos mx. And we've already seen mx gives me m. mx gives me m. Right? See, similarly, suppose I had y equal to sin x power n. Sin x power n to be differentiated with respect to x. Sin x power n to be differentiated with respect to x. One thing is we could go the chain rule. That means I may want to write y as t to power n, where t is sin x. I could have written y as t to power n, where t is sin x. So I have to go from here to here. Instead, y is talking directly to t. So dy dx is like dy dt into dt dx into dt dx. Right? That's the constitution of the chain. Hey, differentiating t to power n with respect to t will give me, this is what it is, right? Differentiating t to power n with respect to t. That gives me nt to power n minus 1. And then differentiating t with respect to x. Sin x with respect to x gives me cos x, right? something to the power n gives me n into something to the power n minus 1. Right? Here also, I don't want you to do all this kahuna. What you would want to do is, say if I had y equal to sine x power n, to differentiate y with respect to x, well, go from outside to inside. Outermost is something to power n. Outermost is something to power n. And something to power n, mentally conceive that as n into something to power n minus 1, right? So n into something to power n minus 1, and then transcend this barrier, sin x gives me cos x. See? The outermost is something to power n. See? What's the outermost? Something to power n. I said ddx of x power n is, did you understand this? Like, sure? Okay, ddx of x is nx power n minus 1, right? Now chain rule only, but the rule that I just suggested, go from outside to inside. Outermost is what? Something to power n. So something to power n will give me n into something to power n minus 1. Something to power n gives me n into something to power n minus 1. That's the outermost part of the chain. I'm again going from outside to inside only. Outermost is something to power n. So something to power n gives me n into something to power n minus 1. And then inside is sin x. Sin x gives me cos x. Right? No? Not sure. So if I had, let's say, ddx, if I wanted to, if y is tan x whole cube, and I want to differentiate y with respect to x. Outermost is something to power 3. Outermost is something to power 3. That's going to give me something into something to power 3 minus 1 first. So 3, right, into tan x to power 2, and then go inside. Tan x gives me sec squared. Right, tan x gives me sec squared. I suppose I had y equal to ln sine of cos of x squared whole power 5. Whole to power 5. Alright. dy dx. So the outermost is something to power 5. Something to power 5 would give me 5 into something to power 5 minus 1. 5 into something to power 4. Right? So we've got past the outermost. Come inside. ln gives me 1 by whatever is inside, sine of cos of x squared. Sine gives, then go inside, go past ln is sine. Sine will give me cos. And then come to cos. Cos will give me minus sine of whatever is inside. And then get inside x squared. X squared would give me 2x. Right? Say y is sine of, yeah, tell me. Arey, typo, yeah, don't bother about this. Don't break your heads on all this. Alright? Just don't break your heads on all this. I mean, see, if in this class, this class is supposed to be now mature enough. We've got on to a level where I'm not going to teach you 8 into 2 equal to 16. If I'm saying 8 into 2 is 16, but let's say I'm more involved with you at that point of time than writing on the board, right? So if I end up writing 8 into 2 as 15.99, then don't bother about that. That's trivia. Okay? So come out of the trivia. Let's just focus on the logic, the argument, and the concept. Okay, don't bother about trivia which is associated to what I wrote. Let it all be associated to with what I'm saying and how I'm saying that, right? Not this x squared and x cubed. You're wasting your time, my time, uselessly. Okay, don't do that. So sine of ln of tan x whole to power 9, and I want to differentiate y with respect to x. So outermost is something to power 9. What would it give me? 9 into something to power 9 minus 1, right? And then sine will give me cos see, the sine gives me cos, ln gives me 1 by, and tan gives me sec squared. Are you all there with me? Say now I have y equal to sine of x squared plus x plus 1. Sine of x squared plus x plus 1. Now to differentiate y with respect to x, again go from outside to inside. Outermost is sine will give you cos of whatever is inside. Cos of x squared plus x plus 1. Okay. And then go inside. Inside is x squared plus x plus 1. What's the derivative of x squared? 2x. Derivative of x? 1. Derivative of 1? Suppose I had y equal to ln of x to power 5 plus sin x plus cos x. Right? And I want to differentiate y with respect to x. Go from outside to inside. Outermost is ln. That will give you 1 by x power 5 plus sin x plus cos x. Okay. And then go inside. This derivative of this final function. Derivative of this plus derivative of this plus derivative of this. Derivative of x power 5 is going to be 5x power 4 sin x cos x. Right. Can I wrap this up? Say y is sine of x squared tan x. Sine of x squared tan x. Okay. Now we have a product. In the innermost part, we have a product of two functions, and then finally you will have to deploy the product rule of differentiation. Derivative of first function into second plus derivative of second function into first, finally. But to begin with, initiate the chain. Sine will give me cos. Cos of whatever is inside. Right? And then move to the innermost part of the chain, which is like the derivative of the product of two functions. Derivative of the product would be derivative of first function into second plus derivative of second function into first. So that's like d dx of x squared into tan x plus x squared into ddx of tan x. How about this? Right? Which is cos of x squared tan x into tan x. ddx of x squared is going to be 2x. ddx of tan x is right? Say if I had y equal to now tan of x squared divided by sin x. Tan of x squared divided by sin x. So go from outside to inside. Outermost would give you sec squared. Then right here you have quotient of two functions, derivative of numerator into denominator minus derivative of denominator into numerator divided by denominator squared, right? So like derivative of numerator into denominator minus derivative of denominator into numerator divided by denominator squared, right? So then this would become 2x into sin x. This is ddx of sin x, so cos x into x squared, etc. Does it make sense? Sounds all right so far. So why don't you differentiate the following? All of you, y equal to tan cube x e power x to y equal to sec to power 5 tan sec x 3 y equal to ln sec of cosec of whole to power 10 fourth y equal to cos of sine of x to power 9 whole to power half 5 y equal to x cube plus x squared plus x whole to power 5 by 2 whole to power 5 by 2 y equal to sine cube x ln x. All of you differentiate these functions with respect to x. Stand by. So all right, the first one, this is like tan x whole cube. So outermost is something to power 3. So you get like a 3 times tan squared x e power x and then x e power x, product rule of differentiation, derivative of first function into second function plus derivative of second function into first function. I'm so sorry. There is a sec squared. That means you actually understood. Yeah. There is a outermost is 3 tan squared. Then once you go inside, tan will give you sec squared. Oh, you started with sec squared. That means you actually not understood. You started with 3 tan squared and then you wrote sec squared and then this. Yeah, I mean, they can swap positions, not a problem, right? 3 tan squared, then go inside sec squared and then x e power x, product rule of differentiation. Derivative of first function into second plus derivative of second function into first. All of you did this, right? All right, so that's the first one. Oh yeah, I mean that's what I asked you. Y is, please. Tan x e power x whole cube, right? Outermost is to power 3, something to power 3. So the first element of the chain would be 3 into tan x e power x squared, something into something to power n minus 1, and then go inside tan. Tan will give you sec squared. And then x e power x is the innermost part. You will apply the product rule of differentiation. That means derive x into ddx of e power x plus e power x into ddx of x. How about this? And ddx of e power x is e power x into x, and ddx of x is 1 into e power x. Got me? No. I don't want anyone to be a stoic in the class. Be very expressive and be violent in your expression, yet not losing sight of dignity and decorum. Be pretty violent and upbeat. If I'm looking at you and saying yes or a no, make head movements of significant amplitude so that it becomes noticeable. All right, all of you, keep a smiling disposition in the class. Refrain from notoriety. Enjoy the class with no nonsense. Yet stay relaxed, calm. Calm not to the extent that you carry no expression on your face. Don't become cadavers in the class. Be violent. Be violent. All right. All right. The next one. 2 dy dx. This is something to power 5. So 5 into something to power 4. That's the first. And then go inside. That's sec. Sec gives me sec tan. Gives me sec tan. So sec of whatever is inside. Right? This sec gives me sec of this into tan of this. Right? And then go inside. Tan gives me sec squared of whatever is inside into. And then sec gives me sec x tan x. Problem 3. Dy dx. Something to power 10. 10 into something to power 9. And then ln gives me 1 by, right. Then sec gives me sec tan. Then cosec gives me minus cosec cot of whatever is inside. And then x cube gives me 3x squared. I can explain if you've not understood something here. Something to power half into something to power half minus 1, half into something to power half minus 1. Half minus 1 is minus half. Then come inside. Cos gives me minus sign. Sine gives me cos of x power 9. X power 9 gives me 9x power 8. Right, 9x power 8. How easy it is. Right? Can I wipe this off? Something to power 5 by 2. 5 by 2 into something to power 5 by 2 minus 1. Right. Three by 2. And then go inside. 3x squared plus 2x plus 1. Right. Sixth. This is something to power 3. So 3 into something to power 3 minus 1 first. Then sine will give me cos. Then go inside. X ln x, you'll apply product rule of differentiation. X ln x, you're going to apply product rule of differentiation. Hey, my friend, are you there with me on this? Just in front of you. What's your name? Yeah, you. समझ में आ रहा है क्या? And then finally ddx of ln x means x into ddx of ln x plus ln x into ddx of x is 1. So 1 into ln x plus 1 by x into x, that will be. You understand everything that I have said so far? Sorry? Sine square theta is sine theta whole squared, na? Sine square theta is what? Sine theta whole squared. It's not sine of theta squared, na? Nahin? This square, you got me? Yeah. Sorry? No, the outermost is something to power 3. You have to go from outside to inside. The outermost is 3. So you'll have to first cross this barrier of 3. Then you can come to this. So you'll forget whatever is inside. So 3 into something to power 3 minus 1. And then come to sine. So that makes it cos and then come to this. Sine cube is actually sine theta whole cube. Right? So even though it might appear that, well, it's come inside, but sine square means nothing. Right? It's actually sine theta and square of this. That's written as sine square theta. But it's actually sine theta whole square, right? Now, some more important results in differential calculus. One thing, it's simply a consequence of chain rule that the derivative of y with respect to x is actually the reciprocal of the derivative of x with respect to y. The derivative of y with respect to x is actually the reciprocal of the derivative of x with respect to y. Now this comes in very handy. Let's say one thing, let me define what this means. Sine inverse x. Sine inverse x. What this means is, find an angle y whose sine is x. Find an angle y whose sine is x. That's what this means. That means, for example, if I said sine inverse 1 by root 2, it means find an angle theta whose sine is 1 by root 2. What's that angle? 45 degrees. That is pi by 4. Pi by 4. If I said sine inverse 1, find an angle theta whose sine is 1. 90 degrees. That is pi by 2. If I said sine inverse half, find an angle theta whose sine is half. 30 degrees, which is pi by 6. Pi by 6. Sine inverse root 3 by 2. 60 degrees, that is pi by, and so on and so forth. Right? Which means, if I said sine inverse 1 by root 2 is pi by 4, what it actually implied was that sine of pi by 4 is 1 by root 2. When I said sine inverse 1 is pi by 2, what it actually meant was that sine pi by 2 is 1. When I wrote sine inverse half as pi by 6, what it actually meant was sine of pi by 6 is half. Sine inverse this is pi by 3. Sine pi by 3 is root 3 by 2, etc. Right? This was the implication. So, if I said sine inverse x as y, then what it actually means is that sine y must be x. That's what it means. When I say y is sine inverse x, it actually means that x must be sine y. That's the meaning of this, right? Now, if y is sine inverse x, which is a function of x, if y is sine inverse x, which is a function of x, okay, all of you understand now this inverse implication, right? This inverse implication. Now, if I said y is sine inverse x and I want to find dy dx, I want to find dy dx, okay. What I should do instead is, since y is sine inverse x, I may want to write x as sine y, I may want to write x as sine y. Now, I can differentiate x with respect to y. That means x with respect to y is like sine y with respect to y, and sine of something with respect to that thing is going to be cos of that thing. So that's going to be cos y. Yes or no? right? Dx dy is like differentiating sine y with respect to y. That gives me cos y. But cos y is root 1 minus sine squared y. Cos y is root 1 minus sine squared y. Yes or no? But where sine y is x, where sine y is x, right? Sine y is x. So I could write this as root 1 minus x squared. Are you confused? So dx dy turns out to be root 1 minus x squared. So dy dx will be the reciprocal of dx dy. See, dy dx is the reciprocal of dx dy. So dy dx is going to be reciprocal of dx dy. That's going to be 1 by root. So if y is sine inverse x, then dy dx is 1 by root 1 minus x squared. That's a result that you want to remember. If y is sine inverse x, then differentiating sine inverse x with respect to x will give me 1 by root 1 minus x squared. 1 by root 1 minus x squared. Got it right? Yeah. I just said that differentiating y with respect to x is reciprocal of differentiating x with respect to y. Alright? That's a consequence of chain rule only. Now, we've deployed this. I want to differentiate sine inverse x with respect to x. That's my objective here. What I do is, if y is sine inverse x, can I not write that x is sine y? Could I write x as sine y? Right? Differentiating sine y with respect to y. Dx dy is what? X is sine y is differentiating sine of something with respect to that thing. What would that be? Cos of that thing, right? It's going to be cos of that thing. So differentiating sine y with respect to y is going to give me cos y. Right? But cos y is root 1 minus sine squared y. Sine y is x. So dx dy turns out to be root 1 minus x squared. Dx dy turns out to be root 1 minus x squared. So what would be dy dx? 1 by dx dy, that's 1 by. So if y is sine inverse x, dy dx would be 1 by root 1 minus. Of course not. Sine inverse x is not sine x to the power minus 1. I mean, if that was the case, then sine inverse pi by sine inverse 1, is it like sine 1 to the power minus 1? Yeah. No, but that's if I said sine x to the power minus 1, that's different. In this case, that's different. That's not the same as sine inverse x. That's why I explained to you what sine inverse x. I'm not even calling it sine x to the power minus 1. That I said is sine squared x. But did I even say that this is sine x to the power minus 1? I've been calling this as sine inverse x. Sine inverse x, I already assigned meaning to this. I said sine inverse x means find an angle y whose sine is x. That means sine y would be. That's what inverse means. I have not been saying it's to the power minus 1. To the power minus 1 is different. Sine inverse is not sine x to the power minus 1. It's a different operation. It's a different operation. So, even though sine x to the power 5 by 6 is the same as sine 5 by 6 to the power sine of, it's written this way, but except when this is minus 1. When this is minus 1, it would not imply sine x to the power minus 1, it would imply sine inverse x. It's a different operation. It's a different operation. It's like find an angle y whose sine is. That's what this would mean. Say if I had y is tan inverse x and I want to find dy dx. Can you all work on this? If y is tan inverse x, find dy dx. What's dy dx? If y is tan inverse x, what's dy dx? Not root. Not root. Yeah, see, if y is tan inverse x, can I not say that x must be tan y? And then differentiating x with respect to y is like differentiating tan y with respect to y. That gives me sec squared y. That gives me sec squared y. Differentiating. This is differentiating tan y with respect to y, giving us sec squared y, right? But sec squared y is 1 plus tan squared y. 1 plus tan squared y means tan y is x, so this is 1 plus x squared, that's dx dy. So if dx dy is 1 plus x squared, what would be dy dx? Does it make sense? So if y is tan inverse x, dy dx is going to be 1 by 1 plus x squared, another result that you want to remember. Okay, y is cos inverse x, find dy dx. If y is cos inverse x, find dy dx. Sorry, louder. 1 by or minus 1 by? So y is cos inverse x means x must be cos y. Then dx dy is like the derivative of cos y with respect to y, that's minus sin y, minus sin y. That is minus sin y is root 1 minus cos squared y. Which is root 1 minus x squared. So dx dy is minus root 1 minus x squared. So dy dx would be my reciprocal of this. Dy dx would be minus 1 by root. Another standard result. So if y is cos inverse x, derivative of cos inverse x with respect to x is minus 1 by root 1 minus x squared. Clear? Do the same thing for y equal to cot inverse x. Cot inverse x, y is cot inverse x. root. Right. So if y is cot inverse x must be cot y, and then differentiating x with respect to y is like differentiating cot y with respect to y, which would be minus cosec squared y. But cosec squared y is 1 plus cot squared y, 1 plus x squared. That's dx dy. So dy dx is going to be minus 1 by 1 plus x squared. Reciprocal of dx dy would be dy dx. Clear? Okay, now do the same thing for y is sec inverse x. Y is sec inverse x. What did you get? Right. See, y is sec inverse x. It would mean x is sec y. X is sec y. So what would be dx dy? Differentiating sec y with respect to y would give me sec y tan y. Sec y is x and tan y is root sec squared y minus 1. Tan y is root sec squared y minus 1, which is x into root x squared minus 1. That's dx dy. So dy dx is going to be 1 by dx dy. So 1 by x root x squared minus 1. So ddx of sec inverse x is 1 by x root x squared minus 1. Take y equal to cosec inverse x. Take y equal to cosec inverse x. Absolutely, absolutely. Good. Good, very good. Okay. Y is cosec inverse x means x must be cosec y. Dx dy would be minus cosec y cot y. Minus cosec y is minus x. Root cot y is cosec squared y minus 1 minus x root. cosec squared y is x squared minus 1, or dy dx is reciprocal of dx dy, so minus 1 by x root squared minus 1. So ddx of cosec inverse x is minus 1 by x root x squared minus 1. Right? So you have some more results to take care of. No problem. Now, teach you what's called logarithmic differentiation. Logarithmic differentiation. I hope you've assimilated everything that we've done so far, right? No confusion. Now, if somebody says differentiate log y with respect to x, somebody's log y with respect to y would have been 1 by y, not an issue. Log of something with respect to something would have been 1 by something, right? But now it's log of something with respect to something else. Log of y with respect to x, not with respect to y. Log of y with respect to y would have been 1 by y, right? But now we have log y with respect to x. What we do is we differentiate log y with respect to y. We differentiate log y with respect to y, and then differentiate y with respect to x. You know what I'm saying? See, that's chain rule. It's actually as if dy dy is getting cancelled, and it's ddx of log y. It's actually ddx of log y, as if d by dy is getting cancelled. That's chain rule, consequence of chain rule. If you want to differentiate log y with respect to x, what you do is take the easier way out, differentiate log y with respect to y, and then this is the adjustment that you make. Differentiate y with respect to x so that this dy and this dy are taken care of, right? But dy of log y is 1 by y, is 1 by y. So what I get is ddx of log y. This is an important result. ddx of log y would not be 1 by y, it would be 1 by y dy dx. It would be 1 by y dy dx, a result that you may want to remember. ddx of log y is not 1 by y, but is 1 by y ddx of y. Clear? Similarly, so this was logarithm. If I want to differentiate sine y with respect to y, what would I get? Cos y. But if I want to differentiate sine y with respect to x, I would differentiate sine y with respect to y first. I would differentiate sine y with respect to y first, and then differentiate y with respect to x. Yes or no? That's chain rule. So this is differentiating sine y with respect to y, giving us cos y dy dx. So again, ddx of sine y is not cos y. Ddy of sine y was cos y, but ddx of sine y would be cos y dy dx. Did you understand this? Right? ddx of tan y is not going to be sec squared y. You differentiate with respect to y, right? Tan y, and then differentiate y with respect to x. And dy of tan y is sec squared y. But if you want to differentiate sec y with respect to x, by this time you should be able to tell me that this is sec y tan y dy dx. In fact, you're applying chain rule. Realize that you're going from outside to inside. Outermost is sec, giving you sec tan, and then you're going inside. Last is dy dx, isn't it? That's exactly what we did. Again, outermost is 1 by, right? Log gives me 1 by, so 1 by y, and then innermost is y. That gives me dy dx. Same thing. Outermost is sine, giving me cos, and then y gives me dy dx. Isn't it? Exactly what I told you a little while ago. Now, again, the objective was this. This was peripheral, so that you understood the concept. So, d dx of log y, as it turns out, is 1 by y dy dx. Why on earth do you want to know this? To begin with down the line, would be a lot of money. Say, I want to differentiate x bar x with respect to x. Now, don't tell me it's x into x bar x minus 1. Reason being, see, when I had d dx of x bar n and I wrote it as nx bar n minus 1, then this n was a constant and x was a variable. This n was a constant and x was a variable. In this case, x bar x. This x is a variable, this x is also a variable. I then propose to find dy dx. I then propose to find dy dx. Right? What I do is, I take the logarithm of both sides. If I took the logarithm of both sides, log y would be log of x bar x. And this x will come here, right? This is going to be x log x. This is going to be x log x, right? And now I differentiate both sides with respect to x. Log y is this. So d dx of this will be equal to d dx of this, right? So d dx of log y is d dx of x ln x d dx of x ln x. Hey, but what's d dx of log y? 1 by y dy dx. Not 1 by y, 1 by y dy dx. Actually, I want to find dy dx, right? So I've already arrived at a dy dx from somewhere. Now, this is what? Derivative of the product of two functions. Derivative of the first function into second function plus derivative of second function into first function, right? Product rule of differentiation. So this is like d dx of x into ln x plus x into d dx of ln x. How about it? d dx of x is 1 into ln x. d dx of ln x, 1 by x into x, 1. So what I end up getting is, observe, 1 by y dy dx is ln x plus 1. 1 by y dy dx is ln x plus 1, leading to dy dx equal to y into 1 plus ln x. Y into 1 plus ln x. Hey, but what's y? Y is x bar x. Y is x bar x. So this is x bar x into 1 plus ln x. That's dy dx. Right? I hope it's not getting burdensome yet. Right? It's fine, right? Okay. So let's get a little more ornate. Differentiate y equal to x power sin x. Come on. With respect to x, find dy dx. Find dy dx. All of you. Take log of both sides, obviously, right? So log y is sin x log x. I mean, log of this is sin x into log of this, right? All of you know the properties of logarithm by now, right? And then differentiate both sides with respect to x. So when you differentiate log y with respect to x, what would you get? 1 by y dy dx. That's d dx of sin x into log x, derivative of the first function into second function plus derivative of the second function into first function. Product rule of differentiation. But d dx of sin x is cos x. So this is ln x into cos x plus sin x into d dx of ln x is by x. So here we have 1 by y dy dx. 1 by y dy dx. So what's going to be dy dx? Dy dx is going to be y into this. Is going to be y into this. Right? Where what's y? Y is x power sin x. Differentiate sin x to power x. Differentiate sin y equal to sin x power x now. I hope all of you have understood this. क्या नहीं समझे बोलो? कुछ भी शुरू से बताएं. लॉग लिया, why is this? So log y would be log of x power sin x, right? Log x power m would be m log x. Log x, ठीक है? So that's log y. Now differentiate both sides with respect to x. Right? But what's d dx of log y? 1 by y into d by dx. Derivative of the product of two functions. Derivative of first function into second function plus derivative of second function into first function. right? But ddx of sin x is cos x, so cos x into log x. Sin x, ddx of log x is 1 by x. So the left hand side is 1 by y dy dx. So dy dx would be what? Y into this. Y into ln of cos x plus sin x by x. Hey, but what's y? Y is x bar sin x. So replace this y by x bar. So if y is this, dy dx would be this. So next, I want you to differentiate sin x to power x with respect to x. I want you to differentiate sin x to power x with respect to x. Okay. All of you have understood this part, right? Sin x power x. बोलो ऐसे ही बोलो. ln of sin x का derivative would be 1 by sin x into cos x. See, if you differentiate ln sin x with respect to x, go from outside to inside, 1 by sin x into cos x. ddx of ln sin x. Go from outside to inside. ln will give me 1 by sin, and then sin will give me cos. है ना? हाँ? Of course, this is cot x. You can write this as cot x. I hope you realize ddx of ln sin x is, go from outside to inside, ln will give me 1 by, and then sin will give me cos. So which is cos by sin, that is cot. No? Didn't understand this? हाँ? ये तो चेन रूल ही तो बता रहा हूं शुरू से. If you want to differentiate this, go from outside to inside. ln of something will give you 1 by something, and then innermost sin will give you cos. Yeah, this was just something that was an intermediate part of this problem. I'll just tell you how this is not the answer to the problem. This was one part of the problem. See, y is sin x to power x. Log y would be x log sin x. And then 1 by y dy dx. Derivative of log y with respect to x is 1 by y dy dx. That's going to be ddx of x ln sin x. And what are we going to deploy here? Product rule of differentiation. That means d dx of x into ln sin x plus x into d dx of ln sin x, product rule of differentiation. But d dx of x is 1. So ln sin x plus x into, now d dx of ln sin x, you will again have to apply chain rule. Go from outside to inside. Outermost is ln. ln will give you 1 by whatever is inside. So 1 by sin x, and then sin will give you cos. Right? So this is like ln sin x plus x cot x. And the whole thing is like a 1 by y dy dx. The whole thing is 1 by y dy dx. Yes or no? नहीं समझ में आया? Sure. So this is 1 by y dy dx is this. So dy dx would be y into this. Where what's y? Sin x power x. So you can replace this y by sin x power x. Differentiate y equal to cot x to power x. Differentiate y equal to cot x power x. Correct? Good. Correct? Okay, just match your answer with what I do. So you take the logarithm of both sides. Log y is x log cot x. And then differentiate both sides with respect to x. This will give me 1 by y dy dx is d dx of x log cot x. Product rule of differentiation then. Derivative of first function into second function plus derivative of second function into first function. That's the product rule of differentiation. d dx of x is 1 log cot x plus x. Now go from outside to inside. 1, right, 1 by cot x into absolutely minus cos x squared. So this is all 1 by y dy dx. So dy dx is going to be y into this, where y is cot x to power. Y is cot x to power differentiate sin x to power sin x with respect to x. Find dy dx. If y is sin x to power sin x, find dy dx. If y, I hope all of you have understood this. Pakka? Nahi na? Y is sin x to power x, find dy dx. Find dy dx. Alright. Done. Very good. No, it's not sine of x power x. It's sin x whole to power sin x. Just seems like cot of x to power x. It's actually cot x whole to power x. Right? So there's a difference between the two things. So I wanted to differentiate sin x to the power sin x. No. Hey, please. This is practice. I don't remember all these results. You don't have to learn. The only results that you want to remember is the inverse function results that I gave you. Sine inverse, cos inverse, tan inverse, cot inverse, etc. Not all of this. I'm just making you practice like die-hard nerds. Alright. Okay. Got it? So take logarithm of both sides. Log y is sin x log sin x. 1 by y dy dx. ddx of sin x into log sin x plus sin x into ddx of log sin x. Right? This is log sin x and ddx of sin x is cos x plus sin x into ddx of log x. 1 by sin into cos, right? Go from outside to inside. Outermost is 1 by and then sin will give you cos. No? So this is like log sin x into cos x plus cos x. That's 1 by y dy dx. So dy dx is going to be y into y. Clear? Now, I told you how to differentiate x power n with respect to x. I told you ddx of x power n is nx power n minus 1, where n is a constant and x is a variable. But if I had y is a function of x equal to a power x, where a is a constant and x is a variable, and I want to differentiate y with respect to x, then what I do is, let me take logarithm of both sides. Log y would be log of a power x, that is x log a, right? Where if a is a constant, log a is also a constant, right? So then if I differentiate both sides with respect to x, ddx of log y is 1 by y dy dx is ddx of x ln a. Hey, ln a is a constant, so it will come out, right? Ln a is a constant because a is a constant, so ln a would also be a constant, so ln a comes out, ln a ddx of x, but ddx of x is 1, so this is ln a, right? So I end up getting dy dx as y into ln a, Because 1 by y dy dx is this. So dy dx would be y into ln a, where what's y? Y is a power x. A power x ln a. Now this is a result that you have to remember. If y is a power x, then dy dx is going to be a power x ln a, where a is a constant and x is a variable. Y is a power x, dy dx is a power x ln a. Log y is x ln a. 1 by y dy dx is ddx of x ln a. Differentiating both sides with respect to x. Now I told you ddx of, if m is a constant, m times some y, this m can come out. So m times dy dx, if m is a constant. So this is m, this m comes out, ln a, ddx of x, 1. So 1 into ln a, and then dy dx is y ln a, where y is power x. So if y is a power x, dy dx is a power x ln a. That's a result that you ought to remember then. Y is a power x, dy dx is going to be a power x. Does it make sense? Shut. Right. Now, with this bit of differentiation in place, you're actually all set on the differential part of differential calculus, differential part of calculus. Now, the other aspect is integration. Again, like I said, all that I'm doing right now is very superficial. There is certainly lot more than what I've pretended. All right. But like I told you, I'm just going to do enough so that we can get started with physics. Only to that extent.